Well, you know what they say, life is like a box of chocolates, and you just never know what you're going to get. Today, I went to visit my friend Steve over in Santa Rosa, and traded him my ugly but overhauled and working Valiant for this Shawnee transmitter and receiver, 6-meter transceiver, with a lot of crystals. Big bag of 6-meter crystals and a box of 6-meter crystals, and there's crystals in this radio. So this is, you know, it's kind of a typical garage radio, and just took a damp rag to the outside of it. It's got some little, look like paint spatters or exhaust splatters on the side that won't wash off. But all of the controls are smooth and clean. And the switches work nicely. The VFO for the receiver and the transmitter all work nicely. Chrome's good on the knobs, paint's good on the panel, dial's good. So I said I'll wipe off the outside, I'll open it up, take a look. So let me put this thing on the what do you call it, tripod, and I'll show you what I found. Well, there it is. This is just the way I found it, dust and warts and all. But kind of a typical garage find radio, but I'm pleased to have it. This is one of those radios, you know, you wanted when you were a boy, but you couldn't afford it. You working 6-meter AM with your tour for a receiver and a borrowed homebrew 10-watt transmitter with one crystal on the wrong frequency, and that's all you got. And you know, I remember some guy driving up the highway past where I lived, and I guess he was tuning around his receiver and heard me, and zero beated me with the VFO, and talked to me until he was out of range, which wasn't too long, 5 minutes or something. But he told me he had this Heathkit Shawnee. This is a Heathkit. This is a 6-meter version. There's also a 2-meter version called the Pawnee. This is the Shawnee, also known as the Hot Water 10, the HW-10, and it's basically a 10-watt output 6-meter AM transceiver with VFO and tunable receiver, and they're separate dials. That's the receiver tuning, that's the transmitter tuning. So it'll go anywhere, but you don't need any crystals, but it's got provision for 4 of them. So let's just go through and take a brief look at it. I don't know an awful lot about the radio yet. I've just browsed the manual, but I'll give you an overview of what it's got, what it does, and then I'll start doing what should be done, and taking a damp rag and getting the dust off so it looks pretty instead of dusty and dirty. Alright, let's see. I'm going to prop this up in the back a little bit so I can see things better. And I guess I'll look in the viewfinder and see if you're seeing things better or not. Yeah, that's reasonably good. Okay, double conversion receiver with a cast-coated front end, I guess a pair of triodes and cascode in the front end. Tunable receive, there's no provision for crystal controlled receive. I think that this variable oscillator for the receiver works in the 20 megacycle range, I think. And, well, let's see. I think it's got a first IF around 20 megacycles and a second IF of 2 megacycles, if I remember right. I'll have to go back and look in the book and see. Typical of Heathkit, the engineering is just really superb on the mechanical end. In here, split gears with a spring anti-backlash drive for this drive. So when you tune the knob, if the only way to get any back, you have to force any backlash in this thing, you're actually either stretching the dial string, which is nearly impossible, or you're stretching this little spring in here, which tensions the dial string. So if you lock this in place and really lean on the knob, you'll start stretching that spring in there. So anti-backlash split gears on the receiver VFO, which is really pretty amazing. And you know, I showed you that in the Clegg Interceptor receiver, which costs as much as a new car, and here we've got it in a unit that cost a couple $100. And on the transmitter VFO, we've got the same thing. There's actually 2 split gears here, one for the VFO, which is in this box, and one for the basically pre-selector tuning for the driver and oscillator buffer driver. So it's a 4-tube transmitter. I think oscillator multiplier 6360 final. It says it runs about 8 watts output. That's the carrier output, and 10 watts CW output. Here's the modulator tube, which is a tube that I don't know. It's a dual pentode, the 6DZ, dog Zulu 6 or 7, I forget which. 6 Delta Zulu 7 twin pentode, and this is a push-pull audio amplifier. Thing is capable of producing 15 watts of audio. It's got a provision to use it as a public address amplifier, drive an external horn speaker, and it can provide 15 watts of audio. As a modulator, it's providing about 10 watts of audio. So you figure that your final amplifier is running about 20 watts input, and you're getting 8 or 10 watts out. But fully modulated, that's, you know, 8 watts, 100% modulation, 32 watts PEP, 10 watts, 40 watts PEP. So it's a potent little transmitter for, you know, a 9-pin miniature and a 2-section push-pull modulator. So choices: crystals or VFO by front selector switch, X1, X2, X3, X4, or VFO. So that's all pretty straightforward. The receiver has RF gain, S meter, AVC, which you can turn on and off, adjustable BFO, adjustable noise limiter, and there's supposed to be a squelch on this thing. I'm not seeing the squelch control. They were talking about the squelch control in the manual, and I don't see it. So I'm going to have to read the manual to figure that out. Let's get the manual real quick here. Where the hell did I put it? It's over here. Make sure that the manual I got matches the hot water 10. Well, they talk about a squelch control, so I have to figure out where it is. I don't understand that. Should be right here in adjustable, and I don't see it. Here's the spot switch, the AMCW switch, the AVC on and off, the RF gain control, the BFO, squelch. Oh, You know what? Here it is. It's a variable squelch control, and it's a push-pull switch for the automatic noise limiter. I've got this propped up so it's facing down. I couldn't read the label. So there's the squelch control. RF gain, BFO, squelch control, audio gain here. The mic gain's on the back panel. So this audio gain is just for the receiver. So, okay, so that's it. What I didn't know about this and what I was surprised to find, this is a heavy radio. It weighs 35 pounds for, you know, something half the size of a bread box. This has got was pretty obviously a Peerless transformer in here, a very high quality transformer. Peerless seemed to make all of the Heathkit transformers in this period. They were famous for making high fidelity transformers. This thing has a vibrator power supply and AC supply. So it's what they used to call a universal power supply. 6 volts DC, 12 volts DC using the vibrator, or 110 volts AC, and you just select the plug. And the wiring of the plug determines how it's going to work. So there's your AC plug, and there's another one for 6 or 12 volts DC, and it's associated with a little box with a relay in it, so that the on-off switch is not switching the high current when you run it on DC. So anyway, I think what we got here is probably, I don't know, I'd have to go and see. Like I said, I don't know this radio at all well. I just wanted to show you the basic mechanical construction. This VFO in a box, a heatsink box, is pretty nifty. They shielded this thing to a fairly well. They were really concerned about TFI and spurious noises while you're running the thing mobile, so there's all kinds of filtering to keep hash and interference from coming in through the power line, the DC line, or the AC line, or RF getting back out through those lines. And I turned the thing over, and the whole bottom of it, besides being in this steel case, is completely shielded. This thing is shielded to a fairly well. Now this is not the original bottom plate. In this manual that I got with it, I found an original blueprint from Heathkit. I was amazed to see this. Never seen anything like this. This is an original manufacturing blueprint just for the bottom plate of this transceiver, with welded on nuts and instructions on here to weld on these nuts in a certain way before plating. They went to all this trouble. There's the mechanical detail for welding on this nut on the bottom plate. And this is just one of 100 mechanical elements in this radio. So they were no slouches when it came to designing stuff. And that's pretty much evidence of it. So I'm going to give this thing the damp cloth treatment. And you can see there's a little bit of rust on the chassis over here, but oh well, not going to be the end of the world. Can still read the writing underneath it, so you know, I know how to conserve that kind of thing and keep it from rusting anymore. And we'll clean it up, and when we get done, it's going to be a reasonably presentable radio. It won't be. You know, this is a radio that's been mobile. You can see the scratches on the case. This thing has been mobile. Somebody has replaced the speaker in here with another one and given it a long umbilical. That's not original. Another interesting thing is that Heathkit included a TVI filter in the in the output circuit of this thing, and the output from the transmitter is on this little piece of coax, and it plugs in here, and then there's your coax on the back, coax jack on the back. So they included a TVI filter in this thing, even though it's sold as a mobile transmitter. They knew what people were going to do because it's got the 110 volt supply in it as well. They know people are going to grab this thing and stick it in their shack and start working some DX in 1961. Heck yeah. And it's actually quite a nice little radio. I think Gonset was the main supplier of AM transceivers in this period, and maybe in 61, maybe they were up to the communicator 3, maybe, and that was a receiver that still, or a transceiver. The receiver in it still didn't have a BFO. The transmitter had no VFO. The receiver had no BFO. It didn't have a noise limiter. Can't remember if it had a squelch or not. I don't think it had a squelch. Maybe it did. I can't remember now. It did not have a universal power supply. You got it either as a 6 volt or a 12 volt unit, or maybe it was 110 and 6 or 110 and 12. I can't remember now. I guess that's the way it was. But I think not as sophisticated as this, and certainly this kind of dial and VFO mechanics are indicative of the fact that they were trying to build as stable a receiver and transmitter as they could. And you know, if you've ever tried to copy CW on a Gonset communicator, you know that well, it just wasn't made to do it. Now this thing has a 15 kc wide IF, 15 kc at 6 dB down. That's pretty wide, and I'm kind of wondering why it's not, you know, 6 kcs wide. They designed the transmit audio to be reasonably narrow so that it would, you know, have more punch for a low power transmitter. It's what you want. And you think that they would build the receiver more with a narrower bandwidth for a higher signal to noise ratio, better noise factor, but they didn't. Now I haven't seen the curve on the IF, and 6 dB down is, you know, I guess it's fairly far down, but I think that's kind of a standard measurement point. And I would have expected to see it with a 6 kcif. I'm not sure why these IF cans, why the IF filter is that wide. I just don't know. It's wide enough that if it had, you know, a discriminator, it could copy FM. I just don't know what they were thinking. It wasn't long after this that they came out with, or almost at the same time, they were making 6 meter sideband stuff, and so this is their last AM effort in VHF. At the same time when they were making this, or within a year or so, they had 2 different sideband transmitters. They never had any receivers, but they had 2 different sideband transmitters for 6 and 2 meters, and a low power one and a high power one. And I think there was a 6 meter specific low power one that I had, was a phasing type rig. Very nice little transmitter. So I don't think they made this very long, maybe 3-4 years. High quality, parts intensive. I think this must have been a reasonably difficult kit because there's a lot of stuff happening in this receiver right here that's pretty close together. And it's got a power supply. The power supply is solid state, by the way, except for the vibrator. And all in all, a very very interesting radio, and I'm looking forward to cleaning it up and getting it on the air. Okay, what we're doing is bringing this thing up on a variac, and you get to watch it with me. You can see the dial light over here. I'll give you an idea what the filaments I'm doing. Had to clean the power plug to make it work at all. It was that dirty. Anyway, we only got about 70 volts on it right now, and it's drawing, oh God, let's see, it's drawing 25 watts. So it's got a solid state power supply, so the inrush current is insignificant. So I'm gonna, that's 70 volts, about 90 volts or so, about 85, we should start hearing something. And by God, I think I do. Yep. There's noise. Still only drawing 30 watts or so. There's 105 volts, and we're still only drawing 30 or 40 watts. Gain control works. Stress is not. There's the spot switch. So we got receiver working, we got an oscillator working. Trying to see how it goes. $115 volts, 50 watts. 115 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 volts, transmit. You put the CW key without a key in it, and it goes into transmit. And I'm doing the output here. Well, I don't think I'm going to do that again, but it's working. Let's see if we can give it a real antenna or give it a real antenna. Let's try that. Let's go over here and put the shop antenna on. Hook that to the 6-meter antenna. And then gotta figure out how to get that. That should be right here. So should be a real 6-meter antenna here. Could be. Not very well coupled in here, but there it is. There's the beacon. Well, you can listen to it drift. Let's turn the voltage up a little bit. Well, it's a very dirty radio, but it's hearing a beacon 100 miles away. I'd have to look up my other receiver, but the real signal strength somewhere probably between S5 and S9, depending on which way the antenna's pointed. Thing is drawing 50 watts, and the maximum it'll draw, supposed to draw, is 120 watts in transmit. So I got a feeling we're right about where we ought to be. So I don't know if the receiver's drifting in the DFO. Well, I guess maybe I'm a little spoiled working on the bigger receivers and transmitters. This one, the Shawnee, the things are packed pretty tightly in this receiver strip here. And so it's a little more delicate and a little more difficult to clean than, say, that Valiant that I showed you recently. I guess it's not much different than the Mora receivers that I've done. But anyway, I'm trying to be delicate with this one, and I just have an inkling that it's not a great idea to put soap and water in this one, and I don't know why I feel that way right now. But I think it's just because everything is so tight. So I'm just using rubbing alcohol and water. And part of the reason is that in the dim, distant past, this radio was in some kind of a smoking environment, and I think it's probably been in a garage for a long time. But the good news is that it plugged in and played right away. I put this thing on the Variac and brought it up, and it came up fast. There was no discernible inrush current, no hum. I was able to tune in 6-meter beacon. It's about 80 miles away, 100 miles away. Showed up on the dial about where it was supposed to be. Heard it okay, and I could even hear it with a 10-foot piece of wire on the clip lead without the antenna. So that's not too shabby. And I let it run here for several hours last night. And after it warmed up, I just turned the volume down, and about every 15 minutes I would listen to it. I had the BFO on and listening to the CW signal from this beacon, and it just would be right there, stayed right there, didn't wander away. It had some drift in the first half hour or so, but after that it just stayed put. So I'm not anticipating a whole lot of real electronic work on this thing. I'm going to clean it well. I'm going to test all the tubes. It's dirty, and I'm taking the garage dirt and a little bit of residue of tobacco there is. It doesn't really stink. Little bit, like it was a smoker 40 years ago. But the rubbing alcohol will take that off. It evaporates right away. Nothing is going to get wet. I thought this dial string on the receiver was working right, but it works right when you come down the scale, but it doesn't have quite enough tension when you go up the scale. And I can see there's a worn spot on the dial string. So the dial strings are complicated. There's two of them, one for the receiver and one for the transmitter. And I can see that, well, I can tell this dial string's a little loose, but it's actually dragging on the top of a couple of pots in here. And there's a little angle bracket in here with a pulley which you probably can't see, but it's right here back behind the VFO. And I want to bend that up a little bit or loosen the screw and raise it up, but the panel's in the way, so I can't loosen the screw. So I think I'm going to end up replacing the dial string on this. I can tell that the tension is not quite what it should be, and so it's slipping on the shaft down here. But probably really would like one more turn against that that tapered shaft to have a little more friction. No, yeah, it goes beautifully one way and not back the other without a little help. So we'll clean and we'll lubricate and we'll see what we can do, but that's going to be one of the things on the list. But I was very pleased with this thing because it, you know, it just worked right away, and those electrolytic capacitors just seem to be wonderful. The inrush current when you turn it on is minimal. It's drawing the correct amount of power, 40 watts on receive, or even a little less. So I haven't really tried the transmitter yet. When I put it in the CW mode, I found that it keyed, and I saw output here on the meter, but I haven't put it on the dummy load. I'll do all the cleaning and test all the tubes before I do that. But looks going to be a good receiver, a good transceiver. Well, I'm just cleaning between the IF cans and the tubes here now with little squares of very damp rubbing alcohol, and then going by with dry squares and a screwdriver. Takes some mechanical work as well as a solvent to get it clean, but you can see that it's cleaning up pretty nicely. There's little patches of rust in places, but most of it doesn't have rust, and it's just superficial. So we got lucky with this one. Okay, we've got the thing clean pretty well. Taken all the tubes out. Shot the tube sockets with deoxit. Be sure the tube pins were straight. Shot them with deoxit. Ran them in and out of the tube sockets a few times to make sure all those connections were good and clean. Lubricated the gears. Lubricated this little slide gently on the top of the panel where that dial indicator slides along. Haven't gotten to the bottom one, which is the one for the receiver that I'd like to have move as smoothly as possible. We'll get to it. Well, now we're going to turn it over. But I want to show you one thing to be really careful about. Many things I like about this design. Not wild about drawstrings in general, but sometimes you gotta have them. But the one thing that's really vulnerable on any radio that's got a tuning capacitor pointed sideways and a drum out on the edge is that they're very vulnerable to damage when the radio is out of the cabinet. I can't tell you how many Japanese radios I've seen where they used a plastic tuning drum for the dial string and mounted the capacitor on that side sideways. Somebody's taken it out of the case, turned it over without looking, and broken that stupid drum. This one is metal, but they're very vulnerable. And once you bend them and screw them up, you got a lot of trouble. So I'm going to turn this over now and work on the bottom. But I'm going to be very careful about how I support the radio, and how I'm not going to roll it over, especially not outside. I'm going to lift it up and set it straight down. But boy, if you're moving the chassis around while you're working on it, you really have to be careful of that, because it's pretty easy to damage it if you're not thinking about it. You're sitting in there soldering, you got the radio upside down, you're soldering on it and you decide to move it and you forget. Be freaking careful. So I'm not quite sure how I'm going to do this, but oops, I'm going to try to put support right under the transformer, and of course we're going to make the whole thing flop around. So
yeah, that's fantasy composer and showman here at the station.
well, it's sitting on the transformer and not on this electrolytic cap. Sitting on the VFO can on that side, which is very rigid, and the transformer, which is very rigid. And this thing got about an inch underneath it. It's vulnerable. So I think what I'll do is get out my my oilcloth that I put on the top of the workbench and put that there, so if I slide it around a little I won't be scratching that transformer up. Well, I had a UPS priority mailbox, a little one there. That's a nice slippery piece of cardboard, so I put that under there so this can slide and then the whole cardboard will slide easily on the workbench. So that's what I decided to do. So I'm going to take this cover off. I think this perforated cover, somebody made that, but they did a beautiful job. Look at all of the screws, and everything is laid out just perfectly. So I'm going to take that off and take a look at what's under the chassis, see if anything needs cleaning up. If there's capacitors that need changing, I'll do that, and hit all switches with the oxit. Okay, this is rather unique among 6-meter transceivers of this era. I think rather remarkably so. Well, let's take a look at what's here. There were, I think, 42 screws that held on this bottom plate. Now this is somebody's homemade bottom plate made out of cane metal. The original was a piece of sheet metal, and for the most part, I don't think it matters much that this is the front end here, which is in a nice little sealed compartment, and the first conversion oscillator up here is part of this, and they've got feed throughs on everything to keep that 20 megahertz mixer crystal out of the transmitter section and everything else. So it might be good if this was a solid plate here, and of course solid bottom keeps dirt out of the relays and stuff, but everything seems to be pretty clean in here. This was a pretty dirty. Well, I just pulled up dust on my finger here from the chassis, so there is dirt did get in there. There's a relay here. There's a multi-contact relay there. Crystal switches here. One little slide switch here, which turns the audio monitor feature on, or maybe that's the no, that's the PA that's switching it over to allow you to use the thing as a public address system. It's a feature I've never seen on any other ham radio. So anyway, everything is very nicely compartmentalized. Take a look at a video for one of those Lafayette transceivers, and you won't see any of this shielding at all. And from what I remember of Polycoms, which were rather expensive, made at the same time period, I don't remember all this compartmentalization in those, all the shielding at all either. Those are really rather cheaply wired despite their high cost. So this is really very well engineered. You know, those guys in Michigan, I guess, you know, University of Michigan was turning out mechanical engineers and electrical engineers right and left, and they had the audio industry and a whole other bunch of manufacturing industry going on in Michigan. And so clearly Heathkit got themselves some sharp cookies to engineer this thing. This thing is quite complex mechanically, and it has a number of interesting features. One of the interesting things is that the oscillator driver mixer sections are all gang tuned to the VFO with a multi-stage, multi-section tuning capacitor on the top of the chassis. And so when you're tuning the VFO, you're also gang tuning all of these mixer stages and multiplier stages all at the same time, so they're all tracking the VFO frequency. So that's being done with one knob rather than a separate pre-selector or driver peaking. It's all done in the alignment of the transmitter. There's multiple little trimmers down in here as well. There's 4 crystals that you can select, and those are over here actually. This is the receiver. I'm sorry. So that 4 crystals here that you select with this switch, or you select the VFO. The transmitter is interesting in that it has a link coupled output to the antenna with a swinging link. The only other VHF transmitter that I can think of made in this period that has that is my Clegg Zeus. So this is, you take off the transmitter tuning knob, and there's a screwdriver adjustment for the swinging link. Maybe you can see the link moving in here. So that's a loading control for the antenna. And there's also plate tuning and plate loading capacitor. So here's a plate loading capacitor with another screwdriver adjustment. It's broad-banded, and the only front panel control is the plate tuning, and the plate tuning is done through an amazing series of controls. There's a shaft here with the dial string that goes up to this dial string pulley, and this is just free floating on the shaft for this oscillator VFO switches. It just rotates on there. They're using as a pivot point. There's no other connection. And that shaft comes down here, another dial string over to this pulley, to this little tiny tuning capacitor, which will tune 90 degrees from fully meshed to fully disengaged, and that's your plate tuning. So this has, you do all your tuning with an output meter, a relative output meter. You don't dip the plate, you just peak the output. And in the alignment stage for the section of the band you're going to work on, you set the antenna coupling with the swinging link and the plate loading with this variable capacitor using screwdriver adjustments, and then you just leave it alone. So if you're going to work down in the bottom portion of the band, 50.4 is the AM frequency, and if the thing worked sideband, you'd be working 50.125 and up to maybe 50.25. CW is down in the bottom 100 kcs of the band, and so are the beacons. So, you know, for most operation these days, you'd set this thing up in the 50 to 50.5 megacycle portion of the 6 meter band. You'd set the tuning and loading for that, and then you just, the only thing you would be doing is doing the plate tuning. The loading would be fixed. So that's quite interesting and rather unique. Certainly simplifies operation for mobile use, giving you one knob transmitter tuning plus the VFO. And you know, the mic gain is set it and forget it. So interesting. Oscillator, driver, multiplier section here, final amplifier section here. This is the power supply in here with buffer capacitor for the vibrator and a big multi-section electrolytic for high and low voltage. In here you've got the audio section with the audio driver transformer, cathode bypass caps for the audio section for the driver and modulator tube. There's one big dual section electrolytic in here, I guess probably for the B+, maybe for the modulator. Two 8 microfarad capacitors at 475, and I guess maybe for the high B+. And as I said, the front end mixer in here, and the rest of the receiver in here, the double conversion receiver, IF detector, and squelch, all in this little section, that receiver strip that we saw on the top where all the tubes in the IF cans are so close together. So this was an advanced construction kit level of difficulty, especially with the mechanical aspects of it. I think maybe the most complicated mechanical dial assembly that I've seen in any of the Heathkits. So it's an interesting piece. This chassis is 1.4 inches deep, less than 1.5 inches deep, and they crammed all this stuff in there. A lot of it's due to miniaturized components. Most of the capacitors, except for 4 electrolytics in here, are all ceramic discs. There's one big multi-section 250 volt electrolytic back here for the low voltage power supply, and I think this must be the high voltage transmitter power supply filter caps. But it's all fitting in this very shallow little chassis. So quite a feat of engineering. We talked about all backlash split gears on the VFO for the receiver and the transmitter. Quite a nifty little transceiver. And I'm going to think about adding double sideband capability to this to make it more usable today. There's almost nobody for me to talk to on 6 meter AM, but on sideband there is, and it's got a BFO. It's stable enough to copy sideband, so I think adding a little balanced modulator, maybe with a couple of diodes, to give it double sideband transmit capability, might bring this thing into the latter part of the 20th century, if not into the 21st, and make it a little more usable. But there we have a quick look at the underside of the Heathkit Hot Water 10, the 6 meter Shawnee transmitter.